Okay, now I'm recording. Okay, an 0.8 kilogram object is attached to one end of a spring, as in figure 1. Okay, and the system is set into simple harmonic motion. Okay, the displacement y of the object as a function of time is shown in the drawing. Okay, with the aid of this data, determine the amplitude of the motion, angular frequency omega, the spring constant k, the speed of object at t equal to 1 second, and magnitude of object acceleration at 1 second. Okay, so how to do this question? First of all, we find out what are the information given. Yeah, so it gives us the mass over here. Okay, we have the mass of the object, and then this is a displacement time graph. Okay, this is a displacement time graph. Okay, so from here we can actually find the amplitude, period, like for example. Okay, first of all, I want you to pay attention to the unit given. Yeah, see, like in displacement. Okay, if displacement is meter, then that means the amplitude also will be in unit meter. Okay, amplitude also be unit meter, and then the time in second, that means the period also will be in second. So pay attention to that. Yeah, if let's say the question says this is not meter, this is centimeter, then the amplitude also will be centimeter. Yeah, if let's say the time is in millisecond, then the period is in millisecond. So you must be careful of all these unit. Yeah, all these unit, but right now it is in SI unit, so time is in second, so period also in second. Yeah, so and then he also mentioned that the displacement is in meter, so the amplitude also in meter. Okay, so good. Well, this diagram help us to get the amplitude already. So this is actually the amplitude, and this is the negative amplitude. Okay, and then period is actually, you can see if one wavelength is actually like one period. Yeah, so this is actually period. Yeah, over here. Yeah, this is actually period. Okay. Okay, so now let's do the question. Yeah, so question A, no problem. Question A, very easy. So A is equal to 0.08 meter. As I said, the unit follow the y displacement. Yeah, so meter amplitude. Okay, and then so the answer is correct. Yeah, and then later question B. Question B, so we want to find the angular frequency, omega. So what's the formula for omega? Omega is 2 pi f. Yeah, 2 pi f, and f is 1 over t. So omega also 2 pi over t. Period, you can find from, the x-axis, which is the time axis. So this is a period. Period is 4 seconds. Okay, so put as 4 seconds. So we get the answer pi over 2 radian per second. Okay, so that's the answer. Okay, so that's correct. And then how about the spring constant? K. Alright, so how about question C? Question C, K, do you know that K actually is equal to m omega square? I did mention already in my lecture video, K omega square many times. K equal to m omega square. Yeah, I see that. K is equal to m omega square. If you want to, can derive K equal to m omega square, come from here, right from here, omega square K over m. Yeah, this one become K equal to m omega square. Or it become period equal to 2 pi square root m over K. So this formula K equal to m omega square actually is the same as period equal to 2 pi square root m over K. Understand? However, just use K equal to m omega square. Refer to my lecture video and you will understand how is this K equal to m omega square being derived. Yeah, K equal to m omega square. So K actually is m omega square. Okay, let's continue. So K is actually m omega square. Do we have the mass? We have the mass. Of course, we have the mass 0.8 kilogram. Okay. So just put in the mass 0.8 kilogram. Yeah, 0.8 kilogram multiplied by omega. Omega is pi over 2. Omega is pi over 2. And then square. Okay, so let's calculate the answer and see what do we get. So pi over 2, okay, square multiplied by 0.8. So I got 1.97. 1.97. So the answer is correct. 1.97. The unit of K is Newton per meter. Do you know why the unit is Newton per meter? Because K is force constant, or spring constant. Actually, it comes from this one. F equal to negative Kx. For this, we will use a y displacement. So Ky. Okay, so K is equal to negative F over y, So the unit of force is Newton, and then unit of displacement y is meter. So that's why it end up with Newton per meter. Newton per meter. This is actually Hooke's law. This is actually Hooke's law. F equal to negative Ky. Yeah. So last time we put as x. Now we put as y. Yeah, y displacement. Okay. So Newton per meter. So that's a unit for K. Newton per meter. Okay. Next question D. Speed of object at 1 second. Okay, I want to find the speed of object. So question D, I want to find the speed at 1 second. If like that, I will need the formula, or I will need to derive the formula for velocity time equation. I need the velocity time equation. So there'll be a lot of process, and then I don't even have the displacement time equation yet, isn't it? Displacement time equation, I don't even have it yet. So I also need to build, displacement time equation. Displacement time equation. So this is a sine graph. Start from displacement. I put as also actually it's y, y time graph. So displacement time graph actually is a sine graph. Sine graph. So follow our notes. Sine graph. Yeah, look at this. Our displacement equation is a sine omega t, and then velocity time is a omega cos omega t, and then acceleration is negative a omega square sine omega t. So use this formula, use this formula. So okay, rewrite the formula. So we need to y equal to y is equal to a sine omega t, and then in fact displacement time graph is a sine graph. Yeah, it's correct. And then velocity time graph is a omega cos omega t. And then we even have like question E. Question E asks for magnitude of object acceleration at 1 second also. So also this one also need acceleration time graph, acceleration time equation. Question E. Question E, it asks for acceleration at at 1 second. Acceleration at 1 second. So this one also need acceleration time equation. Build acceleration time equation. Acceleration is negative a omega square sine omega t. Then you will have to substitute, the amplitude you got just now. Amplitude, substitute into here, and then omega, substitute into here. Omega, substitute on all this. Substitute in all this. Substitute in a omega, and then a omega here, and omega here. Substitute in a omega square omega, and then you get equation for velocity time and acceleration time. At last, you put in the value of time equal to 1 second. I put in the value of time equal to 1 second, and then you can get the velocity. Also for question E, you put in the time. You put in the time of 1 second. You can get the value of acceleration. That's quite a long way to do. Yeah, you will have to build equations of velocity and acceleration to get the value of velocity and acceleration at time equal to 1 second. Okay, that's one way of doing. Yeah, by building equation. Okay, of velocity time and acceleration time. But now I want to teach you a faster way. I want to teach you a faster way of doing these questions because you know, our time in exam is limited, isn't it? This is one way of doing. Yeah, you can get the correct answer also by building equation, velocity time, acceleration time. But however, do you notice that it already give you the graph? Already give you the graph of displacement time. That means it also give you the value of displacement at 1 second. Notice that it gives you 1 second, right? 1 second. So it already give you the 1 second. Okay, let's continue. Okay, so he already give you the displacement at 1 second. You see that displacement at 1 second is, you know, amplitude. Oh, okay. So he already give you this one. You see over here. He already give you. So we can see at 1 second. At 1 second, the displacement is equal to cut off. The at 1 second, the displacement is at amplitude which is 0.08 meter. So write that down first. Yeah, I want you to write that down first. Okay, so I want you to write that down. So you know, so at 1 second, at time equal to 1 second, the displacement is at maximum. Do you know that? At maximum amplitude, which is 0.08. So actually we no need to build all this equation, you know, velocity time and acceleration time, just to get velocity and acceleration at 1 second, because we can straight away use the displacement value here, the displacement value from the graph, displacement at 1 second, and then we use another formula, which is, you know, velocity, which is the formula velocity. To find velocity is equal to plus minus, because we already know the displacement already. See that? So we can use the other formula, which is velocity displacement equation. No need to use the velocity time. Velocity time is much more complicated. We just use the simpler formula, velocity displacement equation, which is plus minus omega square root a square minus y square. Use this one. Understand? So because we already have the displacement from the graph at 1 second, so use this formula, velocity displacement formula. So v equal to square plus minus omega square root a square minus y square. Just substitute all the value. But anyway, do you notice that now y is equal to amplitude? So I no need to substitute all the omega. I no need to substitute all the omega, all the value here. Y is equal to a also. So do you see that a square minus a square become 0? So v is equal to 0 meter per second. So that's the answer. Correct or not? In fact, do you notice that if the object is at amplitude, the velocity is 0? Correct or not? When the object is at amplitude, the velocity is 0. Let me show you one simulation. Okay, let me show you the simulation that I have created. Where is it? SHM. Yeah, spring mass system. Okay, let me show you. Okay, wait a second. Okay, let me show you this animation that I've created myself. Okay, let me show you. Yeah, see that? What is the velocity at amplitude? See the object move to the amplitude, it stops, isn't it? When displacement is at amplitude, yeah, when displacement is amplitude, velocity becomes zero. Velocity becomes zero. See that? See, velocity becomes zero. It stopped for a while at amplitude, but velocity is maximum at the equilibrium. But velocity becomes zero at amplitude. Understand? So that's the animation. Okay, that I created myself. Okay, so that's why when displacement is at maximum amplitude, velocity is zero. Velocity is zero. Understand? So that's the answer. Logic. And then what? How about E? What is the magnitude of object acceleration at 1 second? Also, we can no need to use the formula. Yeah, no need to use the formula of acceleration time. Yeah, we can straight away, because we already know the displacement, so we just use the formula for, you know, acceleration displacement, which is a equal to negative omega square y. Use that one, easier. Okay, so use that one. So we just use the acceleration displacement equation, which is a equal to negative omega square y. Because we already know the at 1 second the displacement is at amplitude. Okay, so displacement is at amplitude. So in fact it is a positive amplitude. Yeah, positive amplitude. It is at positive amplitude. Okay, so put in the value there. Omega square. If you look at here, this is negative omega square a. It is actually a maximum. A maximum, but in opposite direction. Because a omega square is actually a maximum. Yeah, as I taught you before. Y maximum. See that? Y maximum is displacement maximum. Maximum displacement is amplitude. Maximum velocity is a omega. Maximum acceleration is a omega square. A omega square. A omega square. That's the maximum value for each one. Maximum displacement, maximum velocity, maximum acceleration. A omega square. So this one, you got omega square a, which is a omega square lah. A omega square. See, but negative. Let's calculate the value first. Yeah, let's calculate the value first. So negative omega. What's the omega value again? Omega, just now I got pi over 2. Okay, so pi over 2. Pi over 2 square. So what's the A? What's the A amplitude? 0.08. 0.08. So let's put in the value 0.08 meter. Okay, so what's the answer? Okay, I calculated. It is negative 0.197 meter per second square. Let me punch the calculator one more time to make sure everything is correct. 2 square multiplied by 0.08. Okay, and then negative. That's correct. 0.197 meter per second square. Okay, A maximum. Okay, but it's negative. Yeah, the displacement is positive, but the acceleration is negative. Opposite direction. See that? So when y is positive, displacement is positive. The you know, when this at maximum displacement, okay, the a also maximum, yeah, but in negative direction, negative a omega square, negative opposite direction. Okay, opposite direction. You see that? It is opposite direction, positive, negative, opposite direction. So you see, this animation again. This animation again. Do you see that? When displacement is look at here. See, when displacement and is positive, see the displacement and acceleration always opposite direction. You see, always opposite direction, always opposite direction. So when displacement is positive, acceleration is negative. When displacement is negative, acceleration is positive. When displacement is positive, acceleration negative. So when displacement is maximum, acceleration also maximum. See that? Displacement maximum, acceleration also maximum. But in opposite direction. I just love my animation. Okay, so okay, so that's all. Yeah, when displacement is maximum, positive amplitude, the acceleration also maximum, but in opposite direction. Okay, which is this value. So it's correct. Okay, so that's all for this video. Okay, I have taught you how to solve these questions. Okay, so please try out the other questions. Okay, see you.